Before going into the topic details, I want to bring your attention to the UPSC coaching programs offered by ClearIAS. ClearIAS offers online and offline courses to help candidates get selected for prestigious government services like IAS, IPS, or IFS. ClearIAS Prelims Cum Mains (PCM) course provides a highly effective study plan, well-organized subject-wise videos, study materials, mock exams, and guidance to cover the entire GS syllabus of UPSC CSE prelims, mains, and interview systematically. As a limited-period offer, there is a 40% discount on our online courses. Enroll now.
India is actually going to have its own first ever quantum computer. So that is the topic. So we'll understand what this particular thing called quantum machine is and this quantum computing is, and what are the different features. You will be aware about the basic features, that is superposition, entanglement, etc. So in addition to that, we'll go for tunneling, interference, etc. So what is actually this current affair event? The event is recently the news came, that is the India's first quantum computer is actually set for launch under the National Quantum Mission. So India is going to have its first ever quantum computer. That is actually the current affair event that is actually seen in the news recently. So we'll understand what this particular scheme is, the National Quantum Mission is actually about. So what is actually the goal of this particular National Quantum Mission? We have this National Quantum Mission. What is the particular goal of this particular scheme? That is what we are going to identify right now. So the basic thing is, when the program started, the initial goal was that in the 3 years, they are actually aiming to have a computer which has got 20 to 50 qubit capacity. So I'll just introduce the concept of qubit also. We know that the general computers have the processing which is happening at the bits. That is the binary, 0 or 1. Either it is 0 or it is 1, that is the bit actually. Now we are actually having quantum computers which is actually going in the qubit network. So that is the basic fundamental unit of processing in quantum computing. That is the qubit. Now we take the qubit here. We are actually planning to have in the 3 years, we were actually planning to have a computer which can handle qubits of up to 20 to 50 units. And then in the 5 years, they were planning for 50 to 100 qubits. And in the next, 30 years, I guess. And in the next actually 10 years. So this is 10. And in the next 10 years, we were actually planning to have a quantum computer which can actually process up to 1000 qubits. So that is the goal, that is the aim or objective of this particular scheme, to develop a computer in the next 10 years which can process of up to 10,000 qubits is the ultimate goal of this particular scheme. So this current affair event is the first step towards that. That is the first ever computer, quantum computer being developed is the important event surrounding that. So we'll go to the particular topic. That there are also discussions that government cannot actually take it forward by itself, just like space technology, etc., like that. Government wants the private sector participation also. So in between that, they are also planning to establish 4 different companies or to help 4 different companies. One thing. Second thing is that they are actually planning to fund 15 startups, identifying them from the college level, that is from the university level. So they know that the future has more interest in this particular field. So they want to catch them young. They want to identify the talent young. So the government is actually under the National Quantum Mission focusing on the next generation. They are looking around different companies and different colleges and universities, and they are going to identify people and companies and startups, etc. They are going to give them funding and they are going to give them training also under the very same mission. So that we have to also keep in our mind. So we'll understand what this entire quantum mission is actually all about. Quantum computing is actually all about. So first thing is that it is the, what is this mission? It is actually for the scientific and industrial innovation research in the quantum computing and all. Who is implementing it? It is being implemented by Department of Science and Technology, which is under the Ministry of Science and Technology only. So we normally say it is DST, Department of Science and Technology. There is a minister also. So DST is actually implementing the very same project. And what is this particular program duration? It is actually being implemented from 2023 to 2030. That is 2023-24 to 2030-31 is the almost one full decade. That is what they are actually planning to implement. And what are the different things which they are actually planning to implement is that the mission. What is the mission? The mission is to develop magnetometers with high sensitivity in atomic systems and atomic clocks for precision timing, communication and navigation. The point is magnetometers, what they're actually aiming to achieve for. We already heard the word NAVIC. Like NAVIC is there. That is our own IRNSS, Indian Regional Navigation Satellite System. So in between, in that we already mentioned previously that there are actually 7 satellites, etc. So these satellites are actually working in together, not working in silos. In silos means working independently. So working together means that each satellite will know the location of the other satellite. So they can work coordinately. So what if these satellites are working together? What if these systems are working together? They need to know the precise location, the precise time. It is not like, okay, I'll be above, Gandhinagar at 11 a.m. in the morning. Okay, I'll be above Delhi at the 10 a.m. in the morning. Not like that. They'll have that exact, very precise data about time and all. So to maintain that very precise data, what they're actually going for that, they're not going for normal random clocks and watches actually. They're going for atomic clocks. So when you go for atomic clocks and all, it is there we use this particular thing called magnetometers, where precision timing, precision communications and navigations can actually happen. So that is why we are actually pushing forward to this particular mission. And the next thing is that other objectives of the mission is support the design and the synthesis of quantum materials. So there are certain physical materials which actually support this quantum mechanics, quantum computing. So we have to design and make these kind of products also, such as the superconductors, the novel semiconductor structures, the topological materials for fabrication of quantum devices. Basically, semiconductors and superconductors actually. So that is what we are going to look into, because these kind of superconducting materials and special semiconductor materials, that is what is the physical infrastructure we need. These kind of materials has to be designed and manufactured also. And the next thing is that when we say quantum computing or quantum mechanics, is it what are the things which are actually passing? Quantum means that atomic or subatomic level particles. So which are the atomic and subatomic level particles which can be used to transmit data? Electrons can be there, photons can be there. So multiple subatomic particles can be there. So when you take an atom or subatomic level, take an atom, what is actually in the atom? There is a nucleus, there is a neutrons are there are protons, there are electrons. So these kind of things are atomic and subatomic particles. So these things are actually taken out. It is them which is actually used to transmit data. So what is this thing? The single photon sources, detectors, also all these things have to be developed. The entangled photon sources to be developed for quantum communications, sensing and meteorological applications. Basically, subatomic particles like photons and plus electron sources, everything is actually identified. Such devices have to be manufactured. So that is the point under the National Quantum Mission, creation of raw materials which can use these subatomic particles. And the last point but not the least is implemented by the DST in collaboration with other departments. So this is actually the mission of this particular thing called quantum computing. So effectively with this particular system, what we are actually aiming for, not just long distance but short distance communications also. So not just the long distance secure quantum communications, so not the point secure. Why? Because quantum computing is considered to be more secure than the conventional kind of transmitting data and all. So it is actually going for secure communications for long distance and also satellite based quantum communication. Recently it was China which actually established this thing, that is the quantum computing based satellite communication. So they actually achieved that thing. So that point kind of idea is actually also behind that. And not just then intercity quantum key distribution. So what is this key distribution? What do you mean by key distribution? There was one prelims question, public key infrastructure. I guess in less than 2 or 3 years back in prelims there was a question that public key infrastructure, public key distribution actually. So this is basically cryptography. That is if I want to transfer a particular data to one person to next person, I will never be sending that data just like that. If I want to send my name, I will never be sending that particular. I'll just transfer the data, but that name will be hidden. That cryptographic things are actually there. My name will be altered, and then that message will be something else. we know the very fundamental thing, right, in the computer science and all. We study 9th and 10th standard. That is, that particular data is actually altered. I'll just give you an idea. For example, if I'm sending 1, 2, 3, 1, this is the source and this is the destination. I want to send the data that is 1, 2, 3. But I just type the data, but what it is actually going, I'll just add a key. What is the key? Key may be 3 or plus 3. What happens is that I'll add 3 to each of these particular domains. So that is 1 plus 3 is 4, 2 plus 3 is 5, and 3 plus 3 is 6. So the data which is actually going will be 4, 5 and 6. So it reaches there, and then the destination will also know that the key is actually 3. So what he'll do, he'll minus 3. So he'll get the basic, the original data, that is 1, 2, 3. So in between, if somebody attacks this network, what he'll get? Wrong data. Right, the very basic thing. It is actually used in the earlier war times and all. It is actually called Caesar cipher, something like that. Caesar, at that time, he used to use this kind of ciphering mechanism. That is hidden mechanism. So this kind of key distribution things are actually there, in which there can be established networks in which the data can be hidden. The data can be ciphered or encrypted. That is the word actually. The ciphered or encryption can be used. So that kind of things are also being discussed in the quantum computing mechanisms. So ultimately they can have a very secure long distance network of up to 2000 kilometers and all. They'll also have small kind of distance also, but ultimately it will be secure, right? And to develop powerful quantum computers, we already discussed that in 10 years, 500 to 10,000 qubit, that kind of capacity is actually what we are going to look at. And we already discussed about magnetometers, where atomic clocks and all the precision measurement things are actually being carried out. And then creation of the cutting edge technologies, the new raw materials, the new physical devices, which are actually for the quantum computing era. The next thing is regarding this quantum computing mission, there are these are all theories. We are not reached the science part. So the 4 thematic hubs are actually created by this particular mechanism. 4 thematic hubs are created under the National Quantum Mission. So one is actually for quantum computing. The next thing is actually for communications. The next thing is actually for sensing and metrology. And the next thing is actually for the materials and devices. So these kind of 4 hubs, 4 different sectors are actually created within the quantum missions actually. So they're focusing on one computing on one mission. They're focusing on communications on another wing. Next thing for sensing and metrology, and the next thing is for materials and devices. Creation of manufacturing of physical or hardware devices. That is what they are meaning by materials and devices. Cutting edge technologies, most modern technologies, physical devices, physical semiconductors, superconductors, etc. So these combine together to give what we know as the quantum computing mission actually in India. Right. Now we actually go to the science part of this particular thing. These are all theories. It's very difficult to read the government document. They may have this 150 page document to read this thing. So what I was trying to do is that try to summarize this thing, even though I know that this kind of things will be really hard, because it is actually very raw data. It is not in our own language. It is not very concise. It is the government data. So we have to just tweak it little bit so that revision should be done so that this thing will get into your brain. Otherwise this thing will be lost forever. So make sure that you go through your revision in between regularly. So now we go to what is known as the quantum computing and all the different things. So what is this thing called quantum computing? It is definitely an area of computer science and all. It is using the principles of quantum mechanics and all. So what is this thing? This is actually a particular science which is actually happening on the atomic or the subatomic levels. We already mentioned about that particular thing, which is making use of the photons, electrons, etc. So ultimately this is a multidisciplinary field. So this is a multidisciplinary field in which lot of things are actually coming into play, and it is definitely an aspect of computer science. There will be a lot of mathematics, physics, etc. That is what it is being mentioned. And what this thing in particular thing is that why we are actually going behind this thing. Why normal computer is not that much enough? Is it like that? Yes, the normal computer has got definitely a huge limit, and we have to cross that limit. What if we get a huge task which a normal computer cannot do? So we have to definitely go for the quantum computing and all. So that is why there are certain limitations. So that is why we are actually going for the quantum computing and all. So using quantum mechanics to solve complex problems faster than a classical computers. That is what they are doing. you know what is the atomic, subatomic particles, the electrons, photons, etc. We are actually going into the different features of the quantum computing. What you must be knowing about one or two of or maybe all of them. The first thing is actually about the quantum entanglement. You know what is entangling? That is connected maybe. So maybe we always mention about the example of twins. That is, if there is a twin, if you know any twin brothers or sisters like that, generally the parents say in a very joking manner that it may be sarcasm, but they say that okay, if one person is actually getting fever, one of that twins is actually having a fever. If that person is in Delhi, if the other person is in Kolkata, at the very same time the other twin also will get that fever. These kind of myth and stories are there. So it is just like that myth. It is not a reality, it is a myth only, but it's just like a myth. If you have a quantum particles, these quantum particles will be connected. These quantum particles can be connected. If this is one particle, if this is one particle, this can be connected forever. I will say forever, which means that they will be connected automatically to each of them. So that is the point which is actually called the entanglement or the connection, we can say. So the particles interact continuously in a physical manner. So what is the use of this thing called quantum entanglement? Communication. That is each of these things cannot be separately identified. That is, each of this quantum state cannot be separately described and all. If you want to know the status of this thing, you should know the status of this thing also. So that is one particular thing. Each of this thing cannot be completely independently, okay, say independent, that is a better word, independently described. That is actually not possible in the quantum entanglement area. That is one very important thing. So there is a strong link or the strong interconnection correlation in between the two quantum particles. So if you try to measure one, the other one is affected. That is the point. The next thing is actually about, I'll just give you an example of quantum entanglement itself. So it can be simply separately described or measured, which means that if suppose these two are quantum particles which are actually connected or entangled. If this one particular this thing is actually red, which means that this is blue, just like that. So which means that if this thing automatically becomes blue, then it will be red. Just 1 second. Yeah, this thing is just like this. Not like this, it's just like this. If one is red, which means that two must be blue. If one is actually blue, then two must be red. So when we look at one particular particle, we'll automatically get the status of the next particle actually. That is the point which they are actually saying. So this is actually connected. If we want to measure one, the other thing actually we know how it is. If we are starting to measure one and if we know the status is wrong, we know that the system is compromised. So if we know, we'll know how the system is actually foolproof, or if the system is compromised, we'll automatically understand. That is the point. The next thing is, the next property is actually about, we talked about entanglement, now we talk about superposition. So what do you mean by superposition? When we take the conventional system, which is actually using the binaries, when we use the binary system, we have got bits, that is the fundamental unit. What the bit is actually doing, either it is actually in the 0 state or it will be in the 1 state. So that is so the entire whatever systems we are now seeing, or mobile phone or laptops or everything is actually under the binary system. So even the binary system is that much powerful. So just imagine how the quantum system will be. So it will be either 1 or either 0. So what is this thing called qubit system or the quantum mechanics system? It is widely represented as a sphere in which this particular 0 or 1 can take any type of data. That is, it can either be 0, it can either be 1 also. We cannot determine if it is 1 or 0. It can be in between also. So it can be very multiple two values at the very same time. That is simultaneously this particular qubit can exhibit 0 or 1. Here it is either 0 or 1. This can be 0 or 1 simultaneously. That is the point of superposition. That is, the qubit exists in 0 or 1 simultaneously. So that means, what is the property here? The property here is actually called parallelism. This is called parallelism. So parallelly, it can exhibit the properties of two different status. So parallelism, which means that no sequential processing is actually required. So here it is sequential. If you have actually studied in your high school and higher secondary and all, the normal binary system, just like our phone or our computer, is actually sequential. That is, one direction or one instruction passed at a time. So one instruction is passed, then comes the next instruction, then comes the next instruction, goes on like that. So it is actually going like this. That is the sequential system. But what about this particular thing called quantum mechanics? Quantum computing is that multiple instructions can be passed at the very same time, which means that when the parallelism comes, the speed of the system will be multifold than the binary system. So it is not sequential, it is parallel system. This thing is actually one instruction at a time. That is binary. And even the binary is actually that much powerful. Right. So the next point is actually, we know about the entanglement. Now we spoke about the superposition. The next word is actually the interference. The quantum interference is one particular thing. And this was one particular image available. That is, we can see that if we are going for fishing, if two people are actually going for fishing, if you put the rod in the water, you know that there will be ripples created, waves will be created. So there are actually two waves. So what happens when two waves interact? Two different waves actually interact. Two possibilities are there. What are the two possibilities? It can cancel each other or it can increase also. So what could be the word which we can actually use in the wave mechanics? It is actually called the constructive interference or destructive interference. The very basic physics we studied in the high school. It is actually applicable in the quantum mechanics field also. So what happens is that when two waves are actually on the very same phase, which means that the phase is actually increased, the amplitude is actually increased, but it is actually on the destructive manner, which means that the amplitude will be cancelled out or reduced. So that is the destructive interference. So this interference mechanism is actually also applicable in the quantum mechanics field also. So that is one of the properties. Just like wave interference, just like the character of the waves of a particle, the quantum interference may result in constructive or destructive interference. So that is the third prelims point. Or the question, where the quantum mechanics is not affected by the wave property, or quantum mechanics is not affected by the interference phenomena. No, it is actually affected by the interference phenomena just like the waves, and it can be destructive or constructive also. Then last point, the last character of the quantum computing is actually about the tunneling effect, the quantum tunneling. So what could be it? The very same thing. By looking at the image itself, we can understand the normal conventional means of data transfer. If there is a obstacle, what happens is that it actually tries to bypass it. It cannot actually go through it. That is the thing. Here tunneling means that it can actually go through the obstacle. That is actually the property of quantum computing and all. So basically they are the electrons, photons, or all the subatomic particles, and they may pass through some of the obstacles. Some of the obstacles only, not everything. But they are still saying the quantum mechanics has a more possibility of quantum tunneling, so that they need not worry about that much of obstacles and interference and all. They can simply pass through. So that is the point of what is called as the tunneling. That is, they can pass through the barrier and they can still appear on the other side. Alright, so this is the basic concept, or this is the basic properties of quantum mechanics and quantum computing, which are widely discussed and all. So we'll end up winding with some other small properties about the quantum mechanics and all. We already mentioned about qubits, that are the fundamental particles, just like bits in binary systems. And the basic thing also, bit can exhibit either in 0 or 1, but our qubits, that is in the quantum computing, can exhibit in both 0 and 1 simultaneously. That is the basic property, the basic mechanism in which we realize it is a qubit. Now the thing we have to understand here is how the qubits are actually getting transferred, how these things are actually getting transferred. The two different mechanisms, there are multiple mechanisms, but the main mechanisms in which the physical systems in which the qubits are getting transferred, the first thing is actually about the superconducting circuits. So the superconducting circuits is one method in which it is actually in a cryogenic mechanism. What do you mean by cryogenic mechanism? Cool, that is extremely super cool like that. So the first system in which such qubits can transfer is in a superconducting hardwares and all, which are actually in a cryogenic state. So it is not very cheap to make that. It will be very costly, at least now that these kind of things which are kept in the extremely low temperature will be really difficult. Cryo means super cool or extremely cool. That is the point, cryogenic. And the next thing is that they can actually trap ions. Ions means charged particles, right? So they can actually trap those charged particles, that is called ions, and then it can be manipulated using different kinds of lasers or some other, and this is also kept in vacuums also. So laser manipulation also, and then plus it has to be kept in vacuum also. So to create a vacuum chamber, to create vacuum mechanism, to use laser technology into trapped ions and all, again, it is very costly. So what is the drawback, or what is the not drawback, what is the challenge or concern of the quantum computing mission or quantum computing is that it is extremely expensive, at least now. So it is in the initial phases only, but it is extremely expensive to create cryogenic facilities or super cool semiconductors, laser manipulation, vacuum tubes, vacuum chambers, etc. extremely costly. So that is one major thing which we have to understand. And the conventional system, they are actually using the normal semiconductors like silicon chips and all the small transistors. It can be kept in room temperature. This phone will have that transistor. It can be kept in room temperature also, but not this. That is the problem which we are actually facing. But ultimately, when we solve the thing, the speed will be manifold, which means that it can resolve all those unconventional data and all. And when we think about all the unconventional data, we have to also mention about the Sycamore of Google. So there is one particular computer that is actually called Sycamore, which was actually created by Google, not here, it is actually in 2019. So what happened was that this system, you know this person, right, who's actually the CEO of Google Alphabet only, his name is Sundar Pichai. Born in India, brought up in India, studied in India, now he's actually the CEO of Alphabet and Google. So 2019, the Google announced that Google has cracked what is known as the quantum supremacy. So they actually mentioned what is known as the quantum supremacy. So what is this particular thing called supremacy? It is in a very simple thing, that is a computer, a quantum computer, if it can achieve one particular huge task which a normal computer cannot do, then it can be said that okay, they have achieved supremacy. That quantum computer is workable. It is actually successful. That is the basic concept. So it is a situation in which a quantum device can solve a problem that no classical computer can solve in any feasible amount of time. So that is the point. And in the event of Sycamore, what happened was that they solved a problem in 200 seconds. The Sycamore computer, they solved a problem in 200 seconds. That the original conventional computer would take around 10,000 years to solve. So that computer, our own normal computer would have taken 10,000 years, but the quantum computer that is called a Sycamore, they solved it in 200 seconds. After that, Google came out, disclosed this data and said that we have achieved quantum supremacy. So that was the event that actually happened it is a milestone event that happened in the 2019. And what this was, Google's computer was actually a 53 qubit system. We already mentioned what our aim was. In the next 10 years, we need to have a system, we are planning to have a system, quantum system in which 500 to 10,000 qubit is our aim. So this in 2019 achieved this quantum supremacy. So just imagine this 53 qubit system is actually having that much efficiency. That 10,000 years it will take the normal computer, 200 seconds only it took. So that kind of efficiency a 53 qubit system has. So just imagine what a 10,000 qubit system can do. So multiple, that kind of huge potential is actually there in this particular thing called quantum supremacy. And we'll wind up with the last slide. What are the different advantages and challenges? Just like any other topic, we have to understand pros and cons, advantages and challenges, etc. What can be the advantage? Speed is definitely one of the advantages. So advantage, we can mention ultra fast or that a huge speed can be there. That is the basic thing. And the second thing, anything else? Fast data handling. Yes, data handling. Definitely. Data handling will be more easily, more streamlined and all. So next thing, anything else? Any applications we can say? Maybe in health or drug discovery, maybe. For example, medicines or drug mechanisms. See, if we want to create a medicine, what happens is that we go to the chemical data, chemical molecule structure, etc. of maybe some of the pathogens or maybe the drug also. If we have that quantum computing power, we can actually create the exact drug which is required for a disease. So that chemical computations, chemical analysis can be much easier. So that is one advantage, or you can say application of this particular quantum computing. Just like that, can you identify any other applications Weather forecasting, absolutely. Weather forecasting. How we can actually create more points here in the advantages or something like that. Which is the easiest method or technique which a UPSC aspirant use so that you will get more points? Syllabus, that is the point. That is why you should memorize your syllabus automatically. You don't have to read the syllabus to memorize it, but keep on reading the syllabus whenever you read something else. So make sure that when you read the syllabus, you'll get all the data. So ultimately, you'll know that, okay, the first syllabus, the first paper has got history and all the things. It has got geography also, Indian society also. Second paper has got polity, like that. It goes on like that. Weather forecasting, we can actually definitely mention in first paper geography, and it can also be included in the third paper, science and technology. Third paper, again, disaster management is there. So these kind of things we can include we can take out from the different parts of syllabus itself. So if you have the syllabus in your brain, you will get at least 5 more points than the other person. That is the ultimate summary. So weather forecasting is there. And then the artificial intelligence field. So we are actually in the era of artificial intelligence, definitely. So when the quantum computing mission is actually carrying out, it is definitely focusing on artificial intelligence and boosting it up. So that is one particular thing. And recently there was one event in which in Japan there was a credit card fraud was actually detected. And this was actually done by what is known as the basic concept of quantum computing. They actually helped them Japanese discover the credit card fraud system. So they can make certain systems like the banking systems foolproof with the help of artificial intelligence. And large companies like Google, IBM, everybody is actually working on the artificial intelligence process and all. So that is one important thing. And then the financial analysis and all. Financial analysis. For example, it was in 2008 we had the GFC, that is Global Financial Crisis, GFC. So what if we have such a system, quantum computing system, which can have multiple analysis powers? They can actually predict, or they can say that, okay, some kind of system is actually going up. So there is that balloon effect is there. So it may burst up. So make sure that you do all the things required. So at that time also, there were certain people who alerted the authorities and all that the balloon is actually there. It may burst. The global financial crisis in 2008 time. Nobody believed them. So ultimately what happened was that in 2008, some banks went bankrupt, as in the United States of America, and it was actually widespread. That effect was actually spread across the world also, because nobody believed those people. But what if we have a computer? The computer can analyze the economics and say that safely that something is actually not right. So that kind of financial analysis mechanism, and how to risk the the RBI actually fixes the repo rate, reverse repo rate, etc. So how they are actually fixing, why they are fixing for the inflation, etc. So these kind of computers can help the RBI, help the banks to fix their loan rate, the credit rate, etc., like that. Then we already mentioned about the secure communications. For example, China actually recently joined a satellite, and that satellite is actually called Quest. This Quest satellite is actually deploying the aspects of quantum computing and all. So it is a more secure satellite actually. Then we have to there is a foolproof military connections. Everything is actually possible. Then we already mentioned about the the medicines, etc. And in healthcare also, if you have a cancer, and there is cancerous cells, that is carcinogenic cells within your body, what if using quantum mechanics, quantum computing, they can use the scan, they can easily identify the carcinogenic particles. That is actually very good, right? So this kind of diagnosis, examinations and everything in the healthcare sector can be further developed by the quantum computing and all. Then we already mentioned about the weather forecasting, all the climate modeling, landslide mapping, all the things can be done by the quantum mechanics. And then the industries also. The industries also, for example, if you take any industries, they may have to go for the economics, they may have to go for the supply chain, infrastructure, all the storehouses, everything can be, the research and development, everything can be done by in a better way by the quantum computing. So this is the advantages or the applications. I only told about the 15-20 things or like, but there are 50-100 points you can actually raise in this particular thing. Depends on what you are actually reading. If you are reading more newspaper, you will get more data, of course. And some amount of logic also has to be applied. That is the thing. So that you'll get more, even if you don't you can actually create your own points. That is what I'm trying to tell you. And the last thing is actually the challenges what are the limitations which is actually in the quantum computing field? It is very costly, definitely. It is very expensive. That is one very important point.
Time taking.
It is very time taking. So whatever we are doing, it will definitely time taking mechanism.
It's still there.
Skill is actually there, which means that the human resource have to be developed, right? So the number of people which is required in this particular field is immense. But are we properly training our students or our next generation in this particular field? There are definitely trainings and in between some basic trainings definitely going on, but we have to intensively focus on our future generations to train them or to upskill them in this particular area. That is actually extremely important. And we already mentioned about the superconducting natures, the cryogenic technology has to be developed for this thing. All these are extremely expensive, and all the vacuum chambers, all the things. So which means that it is a very complex mechanism which even a normal scientist will not be able to understand. So you need to be a high skilled scientist to do all these kind of things, and such number is actually very less. So that is very important thing. And then also we have to also keep an idea about the global standards. I'll give you an idea. That is when the electric vehicle revolution is actually kicking right now also. So these electric vehicles, you need to plug it right to some plug point. So earlier when the electric vehicles were coming up, one electric vehicle which could have been a plug, which had the plugging standards, right? That standards were different in the United States, and it is actually extremely different in Asia also. So that is the point. So if any of you buy iPhones and all other chargers from United States from your cousins or friends, etc., you need to get an extra adapter because it may not fit in our Indian standard plug point. Just like that very same issue actually happened for the electric vehicles also. So there was a fight between different countries and companies that which standard should come up. So that particular point is actually here also, because it was the different IBM, that is IBM and Microsoft, they had a problem that they were saying that okay, my standard should come up the global standard. But the IBM was saying no, my standard will be the global standard. So that kind of clashes are there. So my concern is that the global standards have to be optimized so that everyone actually can come together, everyone can actually invest, and every countries can actually create and manufacture such kind of quantum mechanics products. Otherwise, every country will be doing in their own ways and there will not be any global standard. So that development will be very slow. So that point has to be understood, and then more research and development and more dedicated courses has to be developed. And we have two different courses like in IIT Madras and in Indian Institute of Science and all in Bangalore. They have the basic course in quantum mechanics and all. There is a quantum technology center in Bangalore, IISc also. But still, we need more and more investment, which is actually not that enough. So if we have proper investments and all, proper upskilling and all, we'll have better quantum computers in future. That is the point. That is a thing we are actually raising.